Alrighty, so in this video I'm going to be showing you guys how you can make your own, or how you can build your own quantum computer simulation application using a library that I wrote myself called Quplexity. It's written in assembly, and it's extremely fast. It's optimized, but of course there's still work to do, so I'm constantly improving the library and putting out new releases and stuff. But this is the library right now. You guys more than welcome to take a look. Give it a star if you like it. But there's a release out now, but pretty much what you're going to want to do is you're going to want to go into a directory or project that you're going to be following along with this video, and then you're going to type git clone, and literally just going to copy this address up here, and then you're going to paste that in here, and you're going to hit enter, and it'll clone the Quplexity library repository into your directory where you're going to be working. Once that's done, there's a crucial step here. You're going to see two folders, one named ARM and one named x86. These are like the naming conventions for two different CPUs. You have x86 CPUs and then you have ARM64 CPUs or ARM CPUs. I'm using x86 because I have an Intel based machine, but if you have something like a Raspberry Pi or a new MacBook, like an M1, M2 MacBook, you're gonna definitely need to use ARM, or this will not work for you at all. So you need to know what sort of platform you're on. So I'm using x86, so I'm going to go into this repository here, this directory, sorry, here, and you should see two files, one named math.asm and one named gates.asm. This will not be there because I've just created it right now for the sake of this video. I will show you this shell script in a second, but first of all, we're going to make a C file. This is where we're going to hold, all the this file is going to hold all the sort of the brains for the operation. And we are going to need to include the main library for C, and then we're going to go ahead and make the main function just here like that. I'm going to return 0, of course. Good old return 0 if I can spell. And then what we're going to want to do is we're going to want to call an external function. Now the external function we're calling is the one that you can find in gates.asm or math.asm, but for the sake of this video I'm going to show you guys how you can use the infamous quantum gate, I suppose you could call it, the Hadamard gate. So we're going to call it like this. So this takes in a double of qubit. It just takes in a qubit pretty much. And then after you've gone ahead and done that, you're going to want to make a qubit in your file. So this is going to have two arguments in it, I suppose you could call. And then these are just the initialization. This is just the initialization vectors for it. So this is in the state of 0, pretty much. So once you've done that, you're going to need to go down again, and we want to make a variable called result. Now this result would be pretty much what happens after. Actually, we don't even need to create a variable, sorry. You can just call the function. So just call h and then pass in, of course, the qubit that we made up above here. Okay, so once you've called that, you're probably going to want to see your output. So just make a printf function here, good old printf function, and just say result of Hadamard gates. Yeah, spelled that right. Yep. And then we're going to pass in the two numbers of our qubit vector. So after that is done, I'm just gonna have a new line there, and now we need to pass in the two arguments for our qubit. So we want to print the first number in the qubit, and we want to print the second number in the qubit. And then after that is done, if I've done everything correctly, I just put another new line in for good merit. Alrighty, I think that looks good. Okay, so I'm going to right quit that. You obviously might not be using Vim, you might be using VS Code or Emacs or anything like that. Yeah, just edit it how you would. Now I'm just going to show you the run, the shell script file that I have here. So pretty much just going to clear the screen so the output looks nice and it's nice and readable, you know. Now this is a crucial step. If you're on ARM, if you're using ARM, you don't need this at all. You're going to be using AS, just so it'd look like AS and then your files and all that good stuff. But you need to install NASM if you're using x86 and install AS if you're using ARM. So I'm using x86, so I'm going to use NASM -F ARM64 64-bit, and then my function, the header function, the one that's, you know, _h that we used in the C file, comes from the file gates.asm. So I'm going to compile this so I can use it and link it with my C file. So then I've gone ahead and compiled my C file. You need the NoPy bit here, and then you go main.c, and then you're linking gates.o from above here, so we can access that header gate function. And then we're compiling down to a file called quantum sim, which I think is very appropriate. All right, so then you're also going to want to do +x run.shell. This will make it so you can actually run the shell script. So after that's done, we can see if I've done everything correctly, and I have. So there you go. That's what your output would look like. Obviously, there's like 1,000 more functions you can use. You know, C0 to fully gate. There's a bunch, poly gates, got those in there as well. But yeah, have a look for yourself. If you like what you see, please do leave a star on the repository. You know, I'm also happy to take like code proposals if you guys want to add code to it, or you see a mistake that I made in here, which, you know, very well could happen. So yeah, you can sort of propose a change if that happens, or you can add things to it. So yeah, do what you like, have a look, play around with it, and yeah, I'll catch you in the next video.